Moving on in the unit, today we'll work on solving radical equations. And we're going to take some of the tactics that we've used to solve equations previous and give it a little bit of a twist. So you recall we have two tools that we've been using to solve equations ever since middle school. One is called inverse operations, right, which is undoing whatever's been done to the variable. And the second is properties of equality. Anything we do on one side of the equation, we're able to do on the other side of the equation and it stays in balance. Our issue now is that as we're working to get the variable isolated on one side of the equal sign, it's going to be inside a radical. And so before we can isolate the variable on one side, we need to isolate the radical expression by itself on one side of the equation. Once we're able to do that, we're going to square both sides of the equation. Recall that squaring and taking the square root are inverse operations. They undo each other. So when we square a square root, we're left with just the radicand. Once we've removed the square root sign, the radical, now we can go ahead and solve for the variable. So let's begin. Taking a look at a problem like number 1. I have an x that's part of an expression 2x inside this square root radical equal to 4. So the radical is already isolated on one side. My job now is to square both sides of this equation. When I square a square root, I'm left with just the radicand. So 2x equals 4 squared, which is 16. Now I can go ahead and divide both sides by 2. And I end with x equals 8. What if I have a different type of expression underneath the radical sign? Doesn't matter. As long as I have the radical isolated, I can square the square root and I'll be left with just the radicand. X minus 1 equals 3 squared, which is 9. Now let's solve for x. And I find that x equals 10. What if the radical is not already by itself on one side of the equal sign? You want to pay close attention here. This radical sign only sits over the x. The radicand is x. The negative 3 is outside the radical. The times 2 is outside the radical. So we have two different steps we need to take to undo before we can get the x square root of x by itself, and then square both sides. So I begin by adding 3. So 2 times square root x equals 4. Now, square root x has been multiplied by 2. To undo that, I divide by 2. So the square root of x is equal to 2. Now I can square both sides. And x is equal to 4. Can I still use these tactics if it's a cube root? Absolutely. If I cube a cube root, I'm left with the radicand. So the cube root of the quantity x minus 3 cubed is just x minus 3. 2 to the third power is 8. And you can see if I check this, I put 11 back inside of here. 11 minus 3, that gives 8. Cube root of 8 is 2. The original equation checks. What about something like number 5? The cube root is not yet isolated on the left side of the equal sign, and you subtract 5 from both sides. So the cube root of x is equal to negative 2. Now, careful here. I need to cube both sides. So when I cube a cube root, I'm left with just the radicand. Now, negative 2 to the third power. Negative 2 times negative 2, that's positive 4, times negative 2 again, that's going to be negative 8. So x is equal to negative 8. Go ahead and try number 6 on your own. You can go ahead and pause the video and then come back and check your work. So taking a look now at number 6, we squared both sides and we were left with the radicand on the left, 4x minus 3. 5 squared was 25. Now we've got a pretty straightforward two-step equation, which you're pretty well practiced in solving, and we find out that x equals 7. All right, let's take a couple more challenging type of problems as we close out the notes. Here, I'm trying to isolate the cube root on one side, so I'm going to subtract 7. So the cube root of 5x minus 4 equals 3. Now I can cube both sides. 3 cubed, 3 times 3 is 9, times 3 again, 27. And when I cube a cube root, I'm left with just the radicand. 5x minus 4 equal to 27. Now I can divide both sides by 5. Is it okay if I end up with kind of a strange fraction? Well, sometimes that means you should go back and check your work. Sometimes that's just the way the problem worked out. But remember, we can always take this value of x, substitute it back into the problem, work it through, and see if it makes a true statement. So if I substitute 31/5 in for x, 5 times 31 divided by 5, that's going to be 31 minus 4. 31 minus 4 is 27. And then I'm taking the cube root of 27. What number times itself 3 times 27? That's 3. So the equation checks. So yes, even though the answer is a fraction and not a really nice one, it's okay. All right. What about a problem like number 8, where I have square root signs on both sides? Is this okay? Is this legal? Can I square both sides of the equation? Sure. In fact, that's what we've done all along. Square both sides to get rid of one radical sign. We can get rid of 2. So 3x plus 1 equal to x plus 15. Now it's a multi-step equation, variables on both sides. So 2x plus 1 equals 15. 2x equals 14. And x equals 7. Square root of 22 equals square root of 22. It checks. And one final way a problem like that could be presented to you, you take a look at number 9, and I have the two radicals subtracted from one another on the same side of the equal sign, and then that's equal to 0. And you scratch your head a little bit, and you go, well, if I square, both sides, I'm going to get some strange expression here. How can I multiply these things together, and how am I going to take the cube root of that? Let's hold up for a second. If I add cube root x on both sides, now I have cube root 2x plus 15 equals cube root x. Now I can cube both sides. So you can use the back of the paper to go ahead and put together your summary. It's not formalized. I don't have the box back there for you, but you can write down 3 things that you learned, 2 things that you want to know more about, and 1 big question that you still have, and any sketches or graphic organizers or connections to other classes that you want to make, you can do on the back page of your notes as well.